Hello, welcome friends. Here today we analyze the continuous beam by the SDM slope deflection method. Now this is having the one end is the overhang and the last end is a simply supported. As per procedure, we know this Ki first is a kinematic indeterminacy, that always generally we are taking the rotation, because here axial force is not acting, so we are generally consider the rotation at support. So now support this B is a overhang, so having the slope, so there is a IB. Then support C is the internal support, is by default all internal support have the slope, so that is the IC. And last support is the ID, because of simply supported we know there is always slope, so that is the ID. So here is a Ki is equal to 3 and that is IB, IC and the ID. Now next step is to fix end moment. So consider each span. Now this clamp the support means only this having the B support, so only clamp the B support, not the A, because A is a free end. So here clamp this. So this is the anti-clockwise, so here the fixed moment is the clockwise, so this becomes M bar BA. So M bar BA, when you are writing the M bar BA, then check whether the moment is clockwise or anti-clockwise. Now this is the clockwise, so plus 20 into 2, that is the 40 kilonewton meter. Then span BC, having the two support, this support, so both support clamp. So we know this is a sagging, so these both moment are the fixed moments are the hogging in nature, so apply the hogging in nature. Now check this M bar BC, suppose this is B and this is C. So M bar BC, now this is what anti-clockwise, so minus. Due to this we know the moment is what WL square by the 12. If you put the value of WL square by 12, that is the becomes the minus 90. And M bar CB, now this is what is a clockwise, so plus WL square by 12. If you put the value of W is the 30, L is the 6 divided by 12, so this becomes the plus. Then the last span, this is important one, span CD. Now clamp both the ends. This is 80, this is 2 and this is 4. So we know if the moment is anti-clockwise, so always produces the anti-clockwise fixed moment on both the ends. This is the C and this is the D. Now right here the M bar CD. What is here M bar CD is what? This is, now check it, where is the anti-clockwise, so minus M. This is A support, this is the B. So if you are calculating this moment, so multiply this by the B divided by L square. You have taken the B, so take here the A. If you taken the A, take the B. This is the simple process to learn this formula. So this becomes the minus 80 into 4 divided by 6 square into 2 into A is a 2 minus 4. So this becomes the 0. Then M DC is equal to, again this is what anti-clockwise, so minus M. For this moment multiply by this distance A divided by L square. Then if you have taken A here, take here the B. You have taken the B, then write the A. So this is a simple technique to learn the formula, and this value becomes the minus 26.67. Okay, so we have completed the 2 steps. Then go to the third step. That is the writing of That is the writing of slope deflection equation. slope deflection equation. Third step, take the span. Now we have taken this span BA. So span BA. So right here MBA. Plane right here the MBA. So MBA. So right here the M bar BA. Then plus here, because of this overhang, rest of the part, this twice, if you write here twice EI by L here, like routing procedure, this is twice IB plus IA minus 3 delta by L. This is the routing procedure. But here we know this IA is 0 because of fixed end. Now this A is 0 because there is no support, and this total value delta is not here because of this 0, and here initially we are considering this is a clamp, or we can say that for the overhang this total part is the 0, so only remaining the M bar BA. So always in the case of the overhang, the rest of the part means after the M bar BA is always the 0. So directly MBA is equal to the M bar BA, and that is the 40 kilonewton meter. So we got here the directly value of MBA. MBA is equal to M bar BA. Then next is the span BC. So for the BC, right here first I is equal to 2I, then L is equal to 6. Now delta, how to calculate? Delta is equal to, take here the preceding end C, delta C minus delta B. So here delta C and delta B both are the 0, so this answer is the 0. So now if you want to write this equation, what is MBC? So you have taken MBC, to take here the M bar BC plus twice EI by L into B, your first letter, so take here the twice IB plus IC minus, here because delta is 0, so this value is 0, but IB and IC are the unknown displacement, because here this IB and IC, these are the unknown displacement. These are not 0, that we have to find. So M bar BC how much is minus 90. So minus 90 plus 2E, I is equal to 2I, then twice IB plus IC. So this finally becomes minus 90 plus here the 4 by 3 EIIB plus 2 by 3 EIIC. Equation number 1. Then MCB for this span. For BC span, you write BC, then CB is equal to, right here the CB, so right here M bar CB plus twice EI by L. Now starting point is C, so right here the twice IC plus the IB minus 3 delta by L. So we know here delta is the 0. These are the unknown displacement. So M bar is plus 90 plus 2E. Here I is equal to the 2I. So put here 2I divided by 6 into twice IC plus the IB. So finally becomes 90 plus here 4 by 3 EIIC plus the 2 by 3 EIIB. This equation number 2. Then the last Now the last span, that is the CD. So CD, so right here the MCD is equal to M bar CD plus twice EI by L into here what? Starting point is C, so write here twice IC plus the ID minus 3 delta by L. Now here for CD span, I is equal to I, then L is equal to 6, and delta how to calculate? Always the preceding end minus the forwarding end. Preceding end minus this, the delta D minus delta C. So that becomes the 0, because delta C and delta D both are not given in our problem, because here everything not given. So that value is the 0. So delta is 0 means this value is 0. We know C and D, these are our unknown displacement, C and D. So that value we have to calculate. So here it becomes 0 plus twice EI by 6 into twice IC plus the ID. So this becomes what here? 4 by 6 EIIC plus the 2 by 6 EI ID. Equation number 3. Then MDC. So M bar DC right here, DC DC, then plus twice EI by L. Here starting is D, so right here twice ID minus plus the IC minus. So this we know delta is 0 for this span. Then these are the unknown displacement, so these are the not 0. Then here value of DC is minus 26.67 plus 2 EI by 6 into twice ID plus the IC. So this becomes minus 26.67 plus the 4 by 6 EIID plus the 2 by 6 EIIC. So this is the third step that we have completed here. Then next step is to apply the equilibrium conditions. Now next step is the apply equilibrium condition. What here? We have the unknown displacement IB, IC and the ID. So these are the our three conditions, that is sigma MB, sigma MC. So now if here is IB, so here condition is sigma MB. Then is IC, take here the sigma MC. Here is the ID, so take here the sigma MD is equal to 0. Is equal to 0 and here is equal to the 0. So in this way you have to take the three conditions. So now if you take sigma MB is equal to 0, so at the B, how many movements members are joined? BA and BC. So if movement is condition is a sigma MB, so always take the starting point is a B, then B to A and B to C. So here MBA plus MBC is equal to 0. Now MBA, so MBA is a we know is MBA is plus 40, then MBC. So here now we have taken here MBA, that is the 40, then MBC is what? Minus 90 plus 4 by 3 EIIB plus 2 by 3 EIIC is equal to 0. So this becomes 4 by 3 EIIB plus 2 by 3 EIIC is equal to plus and minus becomes the plus 50 is equation number A. So here what we have applied the first condition, sigma MB equal to 0 because of there is a unknown displacement, then sigma MC is equal to 0. Now here at this is C and this is the D. So at the C what? C to B member and C to D. So starting point always the C. So we can say that is MCB plus MCD is equal to 0. So here if you apply MCB, this is a 90 plus 4 by 3 EIIC plus 2 by 3 EIIB. Then next is the CD, algebraic sum. CD is plus 4 by 6 EIIC, yeah, this value MCD plus the 2 by 6 this value EIID. The total is equal to the 0. So here this becomes the, if you take here 4 by 3 and for this IC and this IC, so here 4 by 3 plus the 4 by 6, this becomes the 2 EIIC. Okay, then this is the IC, then this plus the 2 by 3 EIIB plus the 2 by 6 EIID is equal to here, this is the plus 90, that becomes the minus 90. This equation is the B. Then apply third condition, sigma MD is equal to 0. Now this is important condition, sigma MD, here D. So here only the one member here was D to C, only one member. So right here MDC is equal to 0. So now MDC is how much? This MDC minus 26.67 plus the 4 by 6 EIID plus 2 by 6 EIIC, that is equal to 0 here. So this becomes 4 by 6 EIID plus the 2 by 6 EIIC is equal to 26.67, equation C. So what here? Important is what? Unknowns are the 3. So equations are the 3. Now here is a BC in this B, C and D, and here is a D and C. So here put this 3 equation into calculator and calculate the EIIB, EIIC and EIID. Now here is not EIID, so take EIID as a 0 in this case. Here the 3 are the unknowns. In this case, there is not EIIB, so take EIIB as a 0 in the calculator, like this. Here is what? B and C. So here if we take the equation 5, so EIB is 4 in this way, put the calculator 4 by 3, then 2 by 3. Here is not ID, so put here this value is the 0, then last is the 50. In this way we have to put all this value and the calculate this value by using this A equation, B equation and C equation. So these values are the here EIIB, that is equal to 80.27, then EIIC is equal to minus 85.55, and third one EIID, that is 82.78. So now put all this value in equation 1, 2, 3, 4, 5 and these 6, which these are the equations. Now the SD equations. Now this is the SD equation. So here BA we got the value of directly the 40 kilonewton meters. So here we can say that MBA is directly the 40 kilonewton meter. Now the span BC. So here write the MBC is equal to, this value is minus 90 plus 4 by 3 here. IB is equal to 80.27, then plus 2 by 3 into EIC into, this is EIC, put here EIC is minus 85.55. So this answer is the BC, that is the minus 40, because here you have taken the condition what? Sigma MB equal to 0 means B to A, means it means what? Here understand the concept here. B to A and B to C, this combined moment should be the 0. That is why here B to A and B to C, this is the plus 40 minus 40, that equal to 0. Then likewise put the value of MCB here. MCB is 90 plus 4 by 3, then EIC is minus 85.55 plus here 2 by 3, EIB is how much? 80.27. So this value is the calculated. CB, that value is the 29.44. So these are the moments. So do this minutes kilonewton meter. Then M. Now this span is completed. Then go to the span CD. Then CD is equal to 4 by 6 here into EIC. How much here EIC? Minus 85.55 plus here 2 by 6 EID. So plus 82.78. So this value is minus 29.44. So CB and CD, here we apply the condition. What here? sigma MC here, sigma MC. CB plus CD, that should be equal to 0. That is why here CB and CD is equal to the 0. Then last is the MDC. Now MDC is important here. We know this is simply supported. Here should be the moment should be the 0. So this value minus 26.67 is DC plus the 4 by 6. EI is how much? 82.78. Then plus 2 by 6 the EIC. So put here the EIC minus 85.55. So this total is the 0. So in this way we got the value of all the fixed moment MBA, MBC, MCB, then MCD, and last is the MDC. Thank you.